好，欢迎大家来参加今天GIA 的知识交流会。我们今天是请到的是GIA 总部的彩色宝石的研究高级经理 Aaron Palke 来给我们带来的是关于这个紫锂玉，可能有的地方也叫锂紫玉，这个叫法略有不同，但是都是这个Kunzite 这个宝石的意思。紫锂玉或者是紫锂辉石，还有其他一些粉色宝石的宝石学研究这方面的一些知识。然后我现在先说一下，就是我们还是以前的老规矩，在他开始讲之后呢，大家都是处于静音状态。然后如果您有问题的话，请把您的问题写在这个屏幕下方。如果你点的话，会有一个 Q&A 这个地方，你可以把问题写在这儿。然后我们到最后讲快结束的时候，会有一个问答环节，然后我会把大家的问题挑一些给他提出来，然后他会回答。然后依据时间关系，我们可能不能全部回答，但是您的问题会留在这儿，然后他有时间会再跟您交流，私下的进行交流。好，现在我们就开始。Aaron, it's your turn.
All right, thank you, Tao. So I'm very honored and happy to be with you all today, and I'm going to talk about Kunzite and other pink gemstones, as Tao mentioned to you. So before we get started on the gemstones, I want to talk a little bit about color. And more specifically, I want to talk about the color pink and how it relates to the other colors that we're gonna see in our gemstones. So there was this theory, this model developed by two linguists, Berlin and Kay, in 1969. And they looked at different languages around the world and how they describe different colors. And what they noticed was that different languages in the world have different numbers of color terms. So some languages might have very few color terms. Some languages might only have two, like light and dark, or white and black. And what they found was that as languages add color terms, they do this in sort of a predictable way. So what they found was that in most cases, if a language adds a third color term, it's typically going to be the color red. So red is almost always the third color a language would have. And that would be followed by green and yellow, and then blue, and then brown. And finally, at the very end, a language would add the colors purple, orange, gray, and of course, pink.
所以在他开始具体讲这些宝石之前，先跟大家说一下，有一个特别有趣的事实，是关于颜色的。然后这两位呢，Berlin 和这个 Kay， 他们其实是语言学家，就是他俩在1969年的时候，发表了这样一个模型，就是他们发现，其实语言在发展过程中呢，有些语言描述这个颜色的词汇非常少，有些语言系统描述颜色词汇比较多。然后而且他们发现一个规律，就是词汇特别少的时候，比如说只有2个词的时候，那一定是说黑和白，或者就是这个暗和明这2种表达。如果再多加进一个词，比如说变到3个词的时候，那第3个一般都是红色，因为红色好像在这个人的生命当中也是一个比较重要的颜色。然后再往后，如果多加4到5个时候，一般这个绿色、黄色这种词就出来了，然后才是蓝色、棕色，就是粉色基本上要到一个非常发达的语言系统里边才有了。Yes, go ahead.
So what's also interesting about this is that we have these two colors, red and pink, and they come into a language at very different stages in the development of their color terminology. And so red is a language that red is a color that almost all languages have a name for, whereas pink, not so much. And I think the reason for this is that the hue of these two colors, these are very similar colors. So they both have essentially the same hue, only they're different in terms of their lightness and their saturation or their chroma.
所以说这张图上，您看它把那个红色和粉色给标出来，就是红色像很多的语言系统里面都有，因为它就是比较简单的语言系统也会有，粉色是到比较发达的语言系统才有。这2种颜色它其实是同一种色调的，都属于红色调，只不过是到粉色的时候，这个饱和度还有明暗度会下降一些，所以就是等于粉色在红色基础上更加复杂一些。所以只有比较发达语言系统才会表达这个意思。
And so that's shown here. This is a series of color swatches showing a variety of different colors But the important thing is all of these colors have the same hue. So essentially it's the same color, but with varying chroma, which you're seeing across the bottom of the screen going horizontally, and lightness. So as you go from the bottom to the top, the lightness is increasing. And so what we can see is you can start with the color red and decrease the saturation, increase the lightness, and get the color pink without even changing the hue.
这个就是说，它现在这是一套那个色卡，咱们都知道标准的比色卡，所有这些颜色全都是红色调，它色调都是一样的，但是，在平行的这个方向上，它饱和度不一样，然后在竖直的这个方向上，它明暗度不一样。所以，如果我们从红色出发，就是在最右边那个它黑色虚线上面那点红色出发，想得到粉色，那就往左走，降低它饱和度，然后提升它的这个明暗度、明度，然后我们就得到粉色。Next one.
So we'll talk about pink gemstones today, or we'll talk mostly about Kunzite, but we'll also go over a little bit about pink sapphires, pink diamonds, pink tourmalines, rose quartz, and pink garnets.
这是今天大概的一个大纲，就是我们主要都是讲这个粉、紫甚至粉红色系的这些宝石，以这个紫锂玉、紫锂辉石为主，然后它还会再讲一些粉色蓝宝、粉色的钻石，然后还有粉色的碧玺，还有这个蔷薇石英，咱们叫国内一般叫蔷薇石英，就是这种肉粉色的这种石英，然后还有一些粉色的石榴石。Next one.
So to start off, we'll talk about Kunzite. So what is Kunzite? Kunzite is the pink to pinkish purplish variety of the mineral spodumene. Spodumene is a lithium aluminum silicate belonging to the pyroxene family. And so if you want to identify a Kunzite, you can turn to standard gemological properties. So you put the Kunzite on a refractometer, you measure a refractive index of 1.691 to 1.700, is biaxial positive, which can help in its identification. The specific gravity of 3.35 can be helpful in some cases. And finally, you might see fluorescence in a Kunzite from strong yellowish pink orange in long wave to weak yellowish pinkish orange in shortwave UV.
现在就是说大概的，咱们先介绍一下这个紫锂辉石，它的一些特性。它紫锂辉石其实在中文里如果叫这个名字就非常的明显了，它是紫色的锂辉石。那首先它是锂辉石，锂辉石呢又是辉石族这个矿物的一种。然后既然它是锂辉石，它本身含锂、铝、氧硅，它是一种这个硅酸盐。然后其实对这个紫锂辉石的鉴定身份并不难，你可以用常规的宝石学的仪器就可以，比如说这个折射仪，折射率1.691到1.700，然后你可能再测个比重，大概3.35左右，这样基本上就能确定它的这个身份了。然后它可能还会出现这个荧光，然后它如果出现荧光，一般是带黄色调的这个粉橙色的荧光。Next one.
So Kunzite gets its name from this fellow, George Frederick Kunz. He was one of the preeminent kind of pioneering gemologists in the early 20th century. And so what happened was there were these miners in San Diego, where I am now, actually. They were mining these pegmatites for gemstones and lithium. And they found this pink gemstone, and they didn't know what it was. They couldn't identify it. They hadn't seen anything like that before. And so they thought this might be a new variety of a gemstone. So they sent off some samples to George Frederick Kunz. He correctly identified the new gemstone as a pink variety of the mineral spodumene, which hadn't really been noticed before as a gemstone. And so in honor of this fellow, George Frederick Kunz, they named this variety of spodumene Kunzite. It was found originally in San Diego County in the United States, but it's also mined quite often in Brazil, Afghanistan, and Madagascar as well these days.
就是现在这个人大家可能也都比较熟悉，西方人特别熟悉，因为他是这个等于是20世纪初期一个特别著名的宝石学家昆兹，咱们一般中文可能叫Kunz，所以他这个英文名字紫锂辉石的英文名字是以他的名字来命名的。 然后这个最开始发现是在圣地亚哥这边的一个伪晶岩区，其实离 GIA 总部不远，就这个地方然后它那块有很多这个伪晶岩，然后我们知道有碧玺也在那儿，然后这些矿工他们其实是在找这个元素锂的过程中就发现这种粉色的宝石，然后当时也不知道它是什么东西，所以就开采了一些，然后送给当时有很多宝石都送到这个昆兹他那儿去，然后他鉴定一下，发现哇，这个以前好像没有人发现过，所以就把它定名为这个紫锂辉石。然后，所以它原始的发源地是在圣地亚哥，美国的圣地亚哥，但是现在呢，在巴西、阿富汗、马达加斯加这些地方也都有所开采。Next one.
And so that's one of the mines where you might find Kunzite is shown here. So this is a Pegmatite mine. So in pegmatites, the gemstones are found in these pockets, these open pockets within the rocks. So the miners will dig through the rock, hoping to find one of these pockets. And eventually when they break into it, they'll very carefully extract all of the gemstones out of this pocket, as you're seeing here.
这个就是特别真实的一个场景，一个矿工他在一个伪晶岩的这种伪晶岩带的这个矿洞里边，然后其实它就是开采这个伪晶岩里边的晶洞。伪晶岩里的宝石一般都在晶洞里边形成，然后一旦发现这个晶洞的时候，他就特别小心认真的，然后把这个里边的宝石开采出来。Next one.
And so if that miner is lucky, this is what he might find. This is a spodumene crystal within one of these pockets. So he would open up that pocket and see a crystal like this. This color is not quite so pink. So this might not be a kunzite exactly, but this is a spodumene that you would find in one of these gem pockets.
就是如果他比较幸运的话，就能找着这种比较大的晶型又比较好的宝石，像这一个，它是一个辉石的这个晶体，但是，因为颜色，你看它基本上无色，没有这个显示出这个粉色或者紫色，所以基本上不能被叫做紫锂玉或者紫锂辉石了。但是作为矿物标本本身，是一个非常好的晶体，而且体积也比较大。Next one.
And if he's really lucky, he might find something like this. So this is a really world-class specimen of kunzite that this miner pulled out of the ground. You can see the deep, rich color as he's illuminating the stone with his headlamp.
说如果真的是运气特别好的话，那你就找到像这种颜色的这个紫锂辉石，这个就没问题了，因为它颜色这个饱和度非常高。然后它现在其实只用它这个脑袋上戴的这个头灯照着这个晶体就可以看出来，这个颜色非常的好，这个就属于基本上属于最高品质的这种紫锂辉石。Next one.
And I just want to show one more photo of that because it's such a nice specimen and the color is just so rich and vibrant there.
这个是另一个角度，还是刚才那块晶体，然后你看这个颜色是非常饱和度非常高的，非常明艳的这种粉紫色。Next one.
So while we're talking about color, let's talk about the cause of color in kunzite. So we said spodumene is this mineral composed dominantly of lithium, aluminum, silicon, and oxygen. And the crystal structure is shown there on the right. And you're seeing an example of a colorless spodumene on the left. So the thing is, none of these atoms, or these elements in the structure, absorb visible light. So when white light, composed of all the different colors of light, enters the stone, none of that light gets absorbed, it gets bounced around the stone and it comes back out to our eyes. And so what we see is a colorless kunzite.
就是我们刚才说完它性质，再说一下它颜色的成因。就是紫锂玉呢，它本身是由锂、铝、硅、氧这几种主要的元素组成的。然后，但是这4种元素其实每个它都不吸收这个可见光，所以它们并不是致色元素。如果是非常纯净的紫锂辉石的话，那只有这4种元素，它就不能吸收可见光。比如说一束白光打到这个晶体上来，它不会发生任何变化，再反射回去，或者再透射出去，回到观察者的眼睛里，那它还是一束白光。所以你看到的就是无色的这个锂辉石，就没有这个粉紫色。Next one.
Oh, sorry. Okay, so with this colorless kunzite, then what you would see if you had a spectrometer that was capable of measuring how light is absorbed by this stone at different wavelengths, this is what you would see. You would see essentially a flat line because none of the light at any of the wavelengths is getting absorbed into any significant extent.
还是刚才那颗无色的这个辉石，那它如果我们用一个光谱仪去测它，刚才我们是用肉眼看，如果你用一个光谱仪去测它的话，那它出来的谱线就是这样一条，您可能看到那个最底下有一条黑色的线，就是一条平平的线，没有任何的吸收，这也是为什么它不显示任何颜色的这个原因。Next one.
Now, for Kunzite, though, we have a different situation. So in Kunzite, we take some of those aluminum atoms in the structure and we replace them with manganese 3+ or trivalent manganese. And so the thing with this is that manganese 3+ actually does absorb visible wavelengths of light very strongly. And so what happens is that the white light with all of those wavelengths of light enters the Kunzite. The manganese 3+ absorbs certain wavelengths and allows other wavelengths to pass through, causing the pink color.
如果我们把一个非常纯净的这个辉石的晶体里边的一些铝原子，用3价的锰原子代替它，因为铝也是3价的，所以3价锰原子去替代一些3价铝原子的话，情况就发生变化，因为这些锰原子它就会吸收可见光中的一部分，而且吸收非常强。再看左边这个图，比如说一束白光进来以后，它就会吸收部分这个白光。里边有7个组成成分哈，一般咱们说的七彩，吸收一部分，然后让这个粉紫色的这个光透出来，然后人眼看到它就变成了这个粉紫色的颜色，这个宝石本身的体色。Next one.
And this is what that would look like. So with manganese 3+ in the spodumene crystal, we see in the absorption spectrum. So if you have your spectrometer, you measure how light is absorbed by the stone at different wavelengths. We would see this big broad absorption band at about 560 nanometers. So what causes is that as white light enters, a lot of that light around 560 nanometers gets absorbed. So it's absorbing all of the green, some of the yellow, and some of the blue wavelengths of light. And it's allowing all of that violet and the pink to red wavelengths of light to be passed through the stone and return back to our eyes.
就是现在我们再用这个光谱仪来测一下这样一颗粉紫色的这个紫锂辉石，那你会看到这个谱线现在不是平直直线，而是有这个一个很大的一个峰在这个3价锰造成的这样一个吸收峰，这个位置呢大概是在绿光还有一小部分蓝光还有黄色光这个位置上，然后那透出来的光如果是不吸收的，就是透出来就是在这个峰两边的这个位置，这个洼地的这个位置，所以我们看基本上红光都会透出来，然后紫色的光蓝色光也会透出来，所以这两种红紫蓝在一组合就是我们这个肉眼所看到的这个宝石的颜色，所以有时候是粉色，有时候是带一点粉紫色这样。Next one.
So a few things to consider when you're looking at a Kunzite. As we mentioned, the trace amounts of manganese 3+ or trivalent manganese is the cause of the pink color in spodumene. Now, it's important to realize, though, that this can be produced naturally. So natural concentrations of radioactive elements in the growth environment of the Kunzite can produce this manganese 3+. But this can also be created through artificial irradiation. So there are people who will treat spodumene in order to create this manganese 3+ color center to artificially create this pink color in a Kunzite. So it's important to realize that a lot of the Kunzite on the market has been artificially irradiated. And this is a treatment that is not really readily identified in the laboratory. Another thing is that Kunzite has a somewhat unstable coloration. So the pink color of a Kunzite can fade over time. And this can happen if through prolonged exposure to sunlight, or also through the application of heat. So it's important if you have a very fine, nice Kunzite, when you're not wearing it, it's probably important to keep it in a dark place, a dark location in order to avoid fading of the color. And it's also important to avoid exposing the Kunzite to high heat. So when you're cooking or doing other things, not to expose your Kunzite to high heat.
这个他是不是说是这个关于紫锂玉有几点比较有意思也比较重要的事情？如果你是购买紫锂玉的话，你要记住这些，就是这个三价锰这个色芯，就是这个致色原因，它可以是天然形成的，可以是在宝石生长的过程中天然环境给它辐射造成，也可以是人工造成。而且市场上确实有很多这个紫锂辉石的粉紫色是由人工的辐射造成的，但是这种辐射呢，它比较不好检测，所以在实验室里基本上是天然还是人工辐射的，这个是很难确定的。就像很多其他宝石，这个辐射是比较难的这么一点。另外呢，这种粉紫色经过辐照出来的这个粉紫色，它是不稳定的，也就是说，它如果遇到强光或者是加热的话，它这个颜色会退掉。也就是说，您如果购买这个紫锂辉石之后，您一定要把它不佩戴的时候保存在比较黑暗的一个环境当中，而且不要让它接触热源。比如说您做饭或者是什么这些比较容易接触到热源的情况下，就尽量不要佩戴这种宝石，因为它会褪色。Next one.
All right. Now, one very interesting thing about Kunzite is that in addition to that pink color being sometimes caused by artificial irradiation, you can also do another type of treatment to Kunzite. So if you irradiate pink Kunzite, you can induce this greenish color. So these stones here, this pink stones on the left, were irradiated, and then they turn to this green color that you see on the right.
就是还有另外一种这个辐射改色的方法，就是把这个天然的粉色的一般是淡粉色这种紫锂玉，然后辐照给它人工辐照，它会变成绿色，就是现在左边和右边这个对比，您就看出来。
Now, this is actually a very unstable color center. So these green spodumene will fade their color very rapidly. And you can even do this yourself if you take one of these irradiated green kunzites and put it under an intense halogen light. The intense halogen light can cause that green coloration to fade very rapidly.
就是像右边第3颗这个宝石，现在就变回它原来那个颜色了。就这个其实是很容易的。如果您有这样的宝石，比如说辐射的绿色的，改色改成绿色的这种辉石的话，您可以把它放在一个白炽灯下边，可能暴露一段时间，它那个颜色很快就会变回去。您自己可以试试看。Next one.
So a few quality factors to consider with Kunzite. Kunzite is typically very clean. So very high value, very fine Kunzite will have very few inclusions. So it's expected that a Kunzite at the very high end will be almost eye clean. It'll have almost no inclusions. Now, what you might see though, in some cases, you might see some fingerprint type inclusions like you're seeing on the left. Very rarely, you might see some mineral inclusions as shown on the left here as well, but very fine Kunzite should be eye clean. Kunzite is also very strongly pleochroic. So that means that the color you see in the Kunzite is going to change depending on the viewing direction. And actually, the best color is seen looking down the long axis of the crystal, as shown here. This Kunzite is illuminated from the end of the stone through the long axis of the crystal.
紫锂辉石它的如果我们购买的话，它有一些这个价值因素。那这里边比较重要的就是它一般是肉眼情况下是比较干，就是观察情况下是比较干净的。它不像很多其他宝石含很多包体，它是比较少见这种情况。如果有包体的话，可能是比较指纹状包体或者一些矿物包体。它刚才像那个第2张图，那个矿物的包体其实非常非常稀有的，很少见的。所以一般情况下是晶体比较干净的。而且这个紫锂辉石它多色性是非常强，所以在这个切磨的时候，可能这个切磨师要非常注意，要体现它这个颜色最好的这一面。
And finally, Kunzite can occur in extremely large sizes. So this is an example of a Kunzite that was faceted by Viktor Tuzlakov. It weighed in at 660 carats. But there are stones I know of in the Smithsonian Museum in Washington, D.C. that are up to over 800 carats in size. So the really high end and really nice Kunzites can occur in extremely large sizes up to several hundred carats.
就是另外一个特点，给这个紫锂辉石就是它体量比较大，比较大的这种晶体是 不能说是非常少见吧，可以说是比较常见。就是在市场上，你可能也会看到一些比较大的这种紫锂辉石的宝石，成品的宝石。像这张图片上的这个是640克拉。然后这个是一个非常著名的一个切磨师切的，另外在一些比较这个知名的博物馆里，可能有很多这种都是大于800克拉的这种紫锂辉石非常常见，所以一般就是上百克拉的这种紫锂辉石还是比较常见的。
All right, so that's what we have for Kunzite. We'll turn next to pink sapphire. So pink sapphires are the mineral corundum, which is composed of aluminum and oxygen. It's the pink variety of this mineral. And if you had to identify it, you would turn to standard gemological properties. So we put it on the gemological refractometer. You measure a refractive index of 1.762 to 1.770. It's uniaxial negative, which can help in its identification. If you needed to, you could measure the specific gravity of 4.00. And for pink sapphires, you might see some fluorescence under ultraviolet light. So it'll fluoresce weak to strong red. And importantly, in terms of the quality factors of pink sapphire, it's important to know that also that some pink sapphires have been treated at low temperatures, meaning around 700 to 800 degrees Celsius, in order to improve their coloration.
现在咱们讲完那个紫锂辉石，讲一下粉色的蓝宝石。粉色蓝宝石，它是属于刚玉族的蓝的，它组成非常简单，就是3氧化二铝。然后它是常规宝石学仪器鉴定也是比较简单的，就测一下折射率，然后1.762到1.770，这个大家可能都能背下来。我们一般比较熟悉蓝宝的人，然后它的比重4.0左右。这个粉色蓝宝呢，比较值得说的是它。在这个紫外荧光下边可能会显示就是从弱到强不等的这种红色的荧光，然后它是1轴负晶了，当然这个如果您需要这个信息也可以测出来。另外值得注意的一点是，粉色的蓝宝有可能是低温加热改色形成的。Next one.
So let's talk about the color of pink sapphires. Where does this color come from? So with pink sapphires, the color comes from trace amounts of chromium 3+, so trivalent chromium. That's shown here in this absorption spectrum on the left. So we see chromium is absorbing light very intensely at around 400 nanometers, so it's absorbing a lot of the blue light. And it absorbs also at about 550 nanometers. So it's absorbing all of that green and yellow light as well. So what happens is that what's allowed to pass through the stone then is the red light. So at lower concentrations of chromium, that red is observed as pink in our eyes when it's returned to our eyes. Some pink sapphires can have their color modified by the presence of some iron titanium blue coloration. So when you add some of this iron titanium pairs in the stone, you induce a little bit of a bluish coloration, which turns the stone more purplish in color. And this is what I was mentioning earlier with the low temperature heat treatment. Some pink sapphires will be heated to remove a little bit of that purplish component of their color, creating a more pure pink coloration.
就是粉色蓝宝，它的成因颜色的成因就是这3价的铬元素，3价铬代替3价铝。然后这个铬元素呢，从它的这个光谱线上，你就可以看出来有2个大的吸收峰，一个在400纳米左右，一个在这个550左右。所以它400纳米左右那个吸收的是紫色、蓝紫色的光。一部分，然后这个550纳米吸收的是中间的这些绿色，然后黄色、橙色这些光，所以剩下的呢就是红，其实主要是红色光这部分会透出来。然后如果这个粉色蓝宝里边还含有一些这个铁钛这一对元素的话，那它之间这个电荷转移也会吸收一部分光，它会产生我们知道在蓝宝石里产生蓝色，所以一旦有这个原子对出现的话，那就会加入一些蓝色，这个宝石就不纯了，不是纯色的粉色，而是有一点带蓝色调的粉色。这种情况出现的时候，就是像他刚才说的，低温加热的情况下，700到800度左右那个温度加热，就能很容易把这个在氧化环境里边把这个蓝色调给它去掉，然后就留下非常纯的粉色。Next one.
Now let's talk about what actually is a pink sapphire though. So this photo is showing a ruby next to a pink sapphire. And so the important thing to realize here is that the color in both cases is caused by the presence of trace amounts of chromium. So a mineralogist would probably consider these two stones to be the same thing. They're both corundum with trace amounts of chromium. But for gemologists, we're gemologists, so for us, this is a big difference. These are actually two different varieties of stone, and it makes a big difference in the value of the stone, whether it's actually termed to be red or pink.
就是现在这张图上两个宝石，左边是红宝石，右边是粉色的蓝宝。就说从矿物学角度来讲呢，这两种宝石其实是一样，它们都是这个刚玉族的，然后致色这个成因都是微量的铬元素进入晶格致色，只不过这个量不一样。所以在矿物学家看来，可能这两种宝石基本上没有什么太大的区别，但是对于宝石学家来说就区别很大。我们都知道，做宝石的人都知道，这个红宝定为红宝和定为粉色蓝宝价值上可能会相差甚远，所以这个在宝石学实验室里边，这个就成为一个比较重要的一个题目。Next one.
Let's look a little more at this, though. So this is an absorption spectrum of a pink sapphire, a simulated absorption spectrum of a pink sapphire. This color swatch in the middle, I predicted the color of the stone based on the absorption spectrum.
Okay.
And so there's a very small concentration of chromium in this stone, and so it's causing only a pink color. Sorry, okay. Tom, go ahead.
Yeah, we'll stop here. Because we have more， 所以我们先在这儿停一下，因为待会儿会有更多的线出现，所以第一条这个您注意看一下，现在底下那个粉色的线，它的起伏其实很小，你要仔细看才能看到。这个就是当我们给这个晶体里边加入很少量的铬元素的时候，它的吸收谱线起伏非常的小，吸收峰非常的矮，然后通过这个光谱线，其实它可以计算出这个颜色大概它的表象是什么，就是上面这个色卡，这是它预测的颜色。然后它会待会儿会继续往里加入铬，然后这个谱线也会变化，那个色卡的颜色也会变化。Go ahead.
All right, thank you, Del. And as we increase the chromium in this stone, so if we can imagine that we can increase the chromium concentration of this stone, the absorption bands start to increase and we start to get a deeper pink color. And if we increase the chromium concentration even more, you see those absorption bands are going up, the color is getting deeper, more saturated. Now we're sort of in this borderline region between red and pink. And finally, if we increase the concentration of chromium a lot more, we're fully into that red region of the spectrum. And so a stone with this type of absorption spectrum, this type of color would be considered red, and it would be a ruby, whereas the spectrum on the bottom there with that low concentration of chromium is a pink sapphire.
就是像刚才那个第一条谱线之后，那就继续往里边加铬，铬的量越来越多的话，那它颜色这个饱和度，您看越来越深，这个明暗度可能会稍微暗一点，这个然后到了第二个、第三个的时候呢，就接近于这个红色了。第四个就说没问题，它是红色了，就定红宝就没问题。但是这个比如说像处在2、3这个位置呀，特别是3那个位置，这个地儿就比较难定一些。Next one.
All right, so we'll turn next to rose quartz. So rose quartz, of course, is the mineral quartz, which is alpha silicon dioxide. If you wanted to identify this stone, you would put on a refractometer, use the gemological properties. The refractive index is 1.544 to 1.553. It's uniaxial positive, specific gravity of 2.66, potentially some weak fluorescence, weak pink fluorescence in ultraviolet light.
下边我们再讲一下蔷薇石英，这也是一种这个很常见的粉色宝石。它就是2氧化硅，成分非常简单，而且这个如果您鉴定它本身是蔷薇石英的话，并不难，就是用常规宝石学仪器，还是测这个折射率、比重，然后可能确定它的这个精细轴性，然后您就可以确定它的身份。蔷薇石英一般在紫外光下，它有可能是不发任何荧光，但是也有可能是发比较弱的这种粉色的荧光。Next one.
And the really interesting thing about rose quartz in terms of its color is that the color is not derived from the quartz itself. So in most other gemstones, we think of trace elements or trace amounts of chromophores in the lattice of the gemstone causing the color. But in the case of rose quartz, the color is actually coming from these micro inclusions, so little small bits of foreign minerals within the rose quartz. that are causing this color. And so you're seeing on the right here, this is a transmission electron microscope image. So a very small scale, very zoomed in image of these inclusions in the quartz. You see these rod-like minerals in this rose quartz. These are micro inclusions of a mineral that's similar to the mineral demordiorite. And so the demordiorite-like mineral inclusion in the rose quartz is what's actually causing the pink color.
就是蔷薇石英比较有意思的一点是它颜色的成因，它并不是由这个微量元素制色的，而是一种这个包体，它里边一个非常微小的包体。像它右边这张图是透射电镜的图，大概300纳米底下那个有这么一个线，您看那儿300纳米，这个晶体非常微小，就是您肉眼根本就看不到的这种，它是柱状的、长柱状的这种晶体，是一种类似于蓝线石的这种包体，然后让这个蔷薇石英显示这个粉色，并不是因为某个微量元素。Next one.
And that's shown here. So this is an absorption spectrum of a rose quartz. It's got this very broad absorption band around 520 nanometers. That's absorbing all of that blue light, a lot of the green and yellow light as well, allowing red or pink light to be transmitted through the stone. So what you're actually seeing here, this is an iron titanium intervalence charge transfer band within the demordiorite-like mineral itself. And so these are caused by iron titanium pairs in the demordiorite-like mineral.
就是这是蔷薇石英的光谱，然后您其实这个光谱显示的并不是这个蔷薇石英本身，而是蔷薇石英里边这个微小的包体，这个类似于蓝线石的包体，它这个蓝线石包体里面就有这个铁钛这个对儿，这个离子对儿，然后它之间会发生这个电荷转移，然后它会吸收这个绿区，还有这个部分蓝区的这个光，而把这个红区的光基本上是透出来，就变成这个我们肉眼看到的蔷薇石英的这个粉色。
All right, next we'll turn to pink to red diamonds. So diamond, of course, is composed entirely of the element carbon. Diamond is isotopic, so it's singly refractive. It has a refractive index of 2.418, which you're probably not going to be able to measure because most refractometers use a refractive index liquid that's much lower than that. So you'll get what we call an over the limit refractive index reading on a refractometer. It has a specific gravity of 3.52.
下边再非常简短介绍一下粉色的这个致红色的钻石。它钻石我们都知道，就是以前也讲过很多，就是纯的碳组成的，然后还有一些这个微量的元素在里边。它本身是各项同性的，它这个折射率当然一般我们测不到，因为它这个折射油的超过这个折射油的折射率本身，所以太高了你就测不到了。然后这个比重3.52左右，所以其实也是确定它是钻石，其实并不是特别难。Next one.
Now, the color of pink diamond is also very interesting. So when we think about the color in a lot of other gemstones, we're thinking about the presence of trace elements, certain chromophore elements that are present in those stones causing the color. With pink diamonds, it's not caused by this kind of a situation. What's actually happening is that there's deformation within the diamond causing crystalline defects within the lattice. And these crystalline defects are what's causing the color in this case. So what happens with diamonds is that in their geological growth environment, they've been deformed or strained by geological forces. And that strain creates these defects, which absorbs light and causes the pink to red color. And what you're seeing in this photomicrograph on the top there, you're seeing these bands of red color in this pink diamond. And so what happens is that the strain that's accumulated in the diamond during these geological processes is localized within these kind of slip bands within the diamond.
粉红色钻石呢，它的颜色成因也是和大部分财宝是不一样的，不是微量元素造成，这是它最主要的一个成因了，就是由形变造成的。然后这种形变是在这个钻石在形成过程中，这个地质作用力让它形变，然后出现在这个钻石里面出现一些滑移面，然后它会像右上方那个照片，您看这个些平行的线。这些纹理，然后所有这个粉色都是集中在这些平行的线上， 然后下边那个光谱也是，就因为这个形变的出现呢，它会出现一个大的这个吸收峰在550纳米左右，然后这个也是会造成这个红色的光基本上是透出来进到你的眼睛，观察者的眼睛里，所以您看到的是粉红色的颜色。Next one.
All right, and next we'll turn to tourmaline. So tourmaline is this, what we call a supergroup of minerals. And basically what that means is that there's a bunch of different minerals with similar chemical and crystallographic properties that have difference in their compositions. So I'm showing the formula of the tourmaline supergroup here, and it's very complicated. I'm not going to go into too many details about that, but the point of showing that is to show that there's a lot of different ways you can make a tourmaline. And so there's a wide variety in the diversity of tourmaline chemistries, which allows us to have also a wide diversity in the colors of tourmaline. So you're seeing on the right, all of the various colors of tourmalines. Tourmaline can appear in almost any color in the rainbow in gem varieties. Now, when we're talking about pink to red tourmalines, though, we're most of the time talking about the specific mineral elbite, which is the sodium, lithium, aluminum silicate version of the tourmaline supergroup minerals.
然后现在我们再讲一下粉色的碧玺。碧玺其实它矿物学上电气石，电气石本身它是一个非常大的一组矿物。然后您看那个第二行那个，它化学式非常非常复杂，而且它晶体结构也略有不同，化学成分略有不同，所以里边包括很多不同的品种。然后这也是为什么如果它化学成分非常复杂的话，它会显示出更多的有可能不同的颜色。这就是右边这张图片显示的这个碧玺这组矿物，其实是各种只要这个光谱上出现的颜色，它基本上都可以有。但是我们说，如果说粉色的碧玺的话，我们基本是在说这个钠锂电气石这一个品种，然后它会显示出这个粉色。Next one.
All right, so let's talk about how you would identify a pink to red tourmaline. So in the very deep pink varieties, we call the rubellite. Now, and then anything in the sort of lighter tones, lighter saturations is going to be pink tourmaline. You would identify these stones using their standard gemological properties again. So refractive index of 1.624 to 1.644, uniaxial negative, specific gravity 3.06, generally not fluorescent, but sometimes weak red fluorescence. And these tourmalines are often irradiated. So we'll get to that in a minute, but it's important to realize that a lot of pink to red tourmalines in the market may have been artificially irradiated.
就是红色的，当它这个颜色非常饱和的时候，我们一般叫红碧玺；如果它颜色略浅的话，一般叫粉色碧玺。然后鉴定还是不难，然后这是我们也不用重复了，就是测折射率、测比重，然后观察一下它的荧光，荧光可以是从没有荧光到这个弱的红色的荧光。值得注意的一点，这个粉红色的碧玺，它有可能是人工辐照改色造成的，然后它后边会讲这一点。Next one.
So let's look at the cause of the color in pink to red tourmalines. So in pink to red tourmalines, the color is caused by manganese 3+, similar to what we saw with Kunzite. So we have light absorbed very intensely around 520 nanometers, allowing a lot of that red light to be passed through the stone, either as pink or red color. And so also with Kunzite, this manganese 3+ can be created either through natural irradiation or through artificial irradiation. So it happens that in the growth environment in which the tourmaline was growing, there might have been radioactive elements in the growth environment that would have caused this manganese 3+ coloration in the tourmaline. But this process can also be replicated artificially. And some of these stones can be irradiated artificially to induce this pink to red coloration. The pink to red coloration can be reversed also through the application of heat.
这个是粉红色碧玺致色原因，其实和我们那个紫锂辉石差不多，也是这个三价锰致色。然后三价锰呢，它在这个可见光这个范围内，您看也是有550纳米这个吸收，然后让这个粉红色的光这部分光透出来。这种致色原因可以是天然形成的，也可以是人工辐照形成的，天然辐照或人工辐照。然后同时这种颜色也是不稳定的，和紫锂辉石都非常像，它也可以褪色。然后如果您把这个宝石暴露在强光或者是这个热源下边，它会褪色。Next one.
So that's shown here. On the left are some natural color tourmalines, and on the right are some tourmalines that have been artificially irradiated to induce a pink to red coloration.
这个左边的那3颗就是天然的这种淡粉色的碧玺，然后右边这个颜色比较强一些的这个是浮照，人工浮照形成的。
And the opposite thing can also happen. So there are some tourmalines, some copper-bearing tourmalines from the Brazilian state of Pareba and Mozambique and Nigeria that can have this manganese 3 plus coloration. And it's actually, these stones are treated to remove that manganese 3 plus coloration in order to create a more pure blue to green coloration.
这个比较有意思一点，就是有一些这种紫色的碧玺，它特别是这种在巴西、像莫桑比克还有尼日利亚出的这种所谓的帕拉伊巴这种碧玺，它紫色是这个锰。你看三价锰制色的，然后把它这个加热之后，其实是去除掉这个三价锰在这里边的这个角色，然后把那个紫色给它去掉，这样就变成比较纯的蓝绿的这种颜色。就是市场上消费者是对这个紫色并不是太认可的，而是对那个蓝绿的颜色更加认可。因为你一想到帕拉伊巴，那肯定不是紫色的，那肯定是最起码是这个霓虹的蓝色或者绿色这样的石头。Next one.
All right, next we'll turn to garnet to end this talk about pink to red gemstones. So garnet is another supergroup of minerals similar to tourmaline, which means that there's a lot of different varieties of garnets that we can talk about. The ones we'll talk about for pink garnets are pyrope, pyrope spessartine, and grossular.
最后我们再来讲一下粉色石榴石。石榴石本身和碧玺就是电气石那个大族差不多，也是非常大的一组宝石。然后它呢，成分多变，这样，但是都是这个各项同性的。我们一般主要讲的更多的是镁铝流石和钙铝流石，还有这个锰铝流石，这几个品种。Next one.
Now with garnets, again, similar to the other stones, we can identify them through their gemological properties. They're singly refractive index of 1.730 to over the limit, depending on the variety of garnet you're looking at. Specific gravity, again, depending on the species you're looking at, 3.78 to 4.15, typically inert fluorescence. The nice thing about garnets is that they're typically not treated. There's not very many treatments you can do to a garnet to improve the color. And so most of the colors you see in the garnets on the market are typically the color that came out of the ground. And also there's not very many ways you can synthesize natural garnets in the laboratory. So we don't have to worry so much about laboratory grown garnets that are taking the place of the natural garnets.
石榴石，它这个鉴定其实也不是特别难，用常规宝石学仪器基本上可以做到。然后一般也是测折射率、测比重，然后它的荧光反应一般情况下是没有荧光反应的，在紫外灯下。然后给石榴石比较重要一点是，它一般不经过人工处理，所以只要是您市场上看到的这个石榴石，它的颜色，一般它显示的这个颜色应该都是天然形成的，就是人工处理的情况非常少。另外呢，它也没有人工合成这一说，就是合成石榴石是非常难的。有一些人工合成的，比如说像那个异铝流石、嘎加流石那些东西，它在自然界其实它是不存在的。Next one.
Now, most pink to red garnets are going to be colored by the presence of iron 2 plus. So the iron in this stone is absorbing light. And I'm showing a slightly different range of wavelengths in this spectrum. So you're seeing not only the visible light, but also the near infrared light. And the point here is that the iron in this stone is actually absorbing light most intensely in the near infrared. So wavelengths of light that we can't really see with our eyes. But there are some absorption bands in the visible range, which are causing the color of the stone. Those absorption bands are absorbing a lot of the blue, green, and yellow light, allowing the pink light to come through.
就是粉红色的石榴石，它这个颜色也是由二价铁造成的。二价铁它这个光谱，您看就跟刚才那些光谱不太一样，它是既有可见光谱，也有一部分的红外光谱。这个二价铁既吸收红外光谱的这部分，也吸收一部分可见光的，所以中间就剩下那个红色的部分会透出来，就是我们看到的这个红色的体色。
And just some examples of some nice pink garnets. These are some pink pyrope garnets. They're almost near end member pyropes, meaning they're almost pure pyrope garnets from Italy. So they're from this location in Italy called Doramira, which is high up in the Italian Alps. These were caused by subduction of continental crust to great depths, and the metamorphism that subsequently occurred created these pink pyrope garnets.
这个是这些石榴石基本上非常纯的镁铝流石，产自这个意大利的这个阿尔卑斯山区，它是在那种造山带那个超高压变质带里边形成的，属于很少见的，因为这个非常纯的一个具有非常纯的化学成分的这种石榴石是非常少见的。Next one.
And this is a spectacular pink grossular garnet. So grossular can also occur in pink coloration. The color of the stone is likely caused by iron, but there are some grossulars that have their color induced by the presence of trace manganese 3+, creating either pink to red grossular garnets.
这是一颗粉色的钙铝流石，刚才咱们那都是镁铝流石，然后这是钙铝流石，它也是钙占比较大的比重，但是它这个其实它致色原因不是钙，而是铁，微量的铁元素致色。Next one.
And finally, there are some pyrope spessartine garnets, which also have a very intense pink coloration. Importantly, and very interestingly, these pyrope spessartine garnets can have what we call a color change. So if you change the illumination environment from warm incandescent light, where you'll see a nice rich pink color, to cool daylight illumination, you'll go from a sort of a pink color in warm light to more of a purplish color in daylight.
这个是比较有意思的变色的石榴石，它呢是镁锰铝流石，它这个3种元素都有，然后它主要来自东非，然后在这个比如说白炽灯下，它就会显示这种比较温暖的粉色，然后在这个日光灯下呢，它就会略带一些，就有一些蓝色的元素加入进去，所以就有点冷的那种紫色调。这个变色效应不是像那个亚历山大石那种变色效应那么明显，它是同一色调，但是这个冷暖程度不一样。
All right, and with that, that wraps up my talk. And if there's time for questions, I'd be happy to take some.
好，现在呢，咱们进入这个问答环节，大概还有10分钟左右时间。我先来看一下这个问题。The first question is: there a reason why pink color tend to be unstable, like in Kunzite, morganite, and conch pearl? I guess.
Yeah, so I can't speak too much about the conch pearl, but for the stones that are caused by, where the color is caused by manganese 3+, so like morganite and kunzite, this manganese 3+ initially started out as a different variety of the ion. So it was originally a divalent manganese, so manganese 2+, and through either artificial or natural irradiation, that manganese 2+ had an electron stripped from it, and it created manganese, what we call manganese 3+. And so because this was caused by irradiation, so different types of color that are caused by radiation are often unstable. And so what happens is that electron is sitting somewhere in the crystal lattice. The electron that was stripped from the manganese is sitting in the crystal lattice somewhere. And so application of heat, or even sometimes even just light, can oftentimes cause that electron to be recombined with the manganese, sort of destroying the manganese 3+ center. And so manganese 2 does not absorb as strongly as manganese 3. And so that's kind of why there's this instability of the color many times in these pink gemstones, especially when the color is caused by manganese 3+.
Okay, before I translate that, Aaron, can you move to the social media slide?
Yeah, sure.
所以就说锰之色为什么会不稳定呢？因为三价锰这个其实是一个色芯，就是由辐照的话，它把2价锰其中的一个电子给它打掉，然后这个电子呢，它还会在这个晶格里边存在游离着。然后如果您加热或者是这个暴露在强光下的话，你给它一定的能量了，那这个游离的这个电子还有可能回去跟那个3价锰再组合一起，又变回2价锰了，所以颜色就会恢复成原来的，就褪色了。那个珍珠那个他一不解释，因为他不研究珍珠。The next question, can you clarify or just elaborate a little bit more about heat treatment of Pareba tourmaline.
Yeah, so a lot of Pareba tourmaline, or at least a lot of what we call copper-bearing tourmaline, comes out of the ground in purple or violet colors. And so it's actually probably not even correct to call them Pareba tourmaline, because Pareba has to be blue or green. And so what's happening is we have this combination of two chromophores, the copper, which is causing a blue to green color, and the manganese 3, which is causing a pink coloration. So you combine that to get violet or purple. The market tends to like the rich blue and green colors more. So because this manganese 3 is unstable, folks can heat those stones at relatively low temperatures. So we're talking 200 to 300 degrees Celsius is enough to remove the manganese 3. So what you're doing, you're removing pink color by destroying the manganese 3, leaving only the color from the copper to be seen in the stone. And so this is what's happening with the heat treatment. You're taking purple to violet stones and turning them more pure blue or green by destroying manganese 3 plus.
OK， 就是像他刚才也讲过，我就简单说一下他这个帕拉伊巴的话，如果它里边有锰的话，咱们说锰一般在这几种这个粉色的宝石里边，它都是致粉色，然后它里边还有铜，铜其实是那个我们想要的致这个蓝绿色的这个致色原因。如果两个一起出现的话，那就两个加起来一下就变成紫色，紫色消费者就不太喜欢这个颜色，所以给它低温加热一下呢，基本上就可以把这个给它点能量，像刚才那个说为什么那个锰致色它不稳定，把那个锰的颜色给它退掉。那个粉色调给它退掉，然后让它变成比较纯的这个蓝绿色，这样就是你叫它帕拉伊巴的话，消费者就比较认可。Next question, what's the cause for the color shift of those garnets on the last slides?
Yeah, so that's something I didn't go into too much detail, but with garnets, there's actually a variety of different ways you can create that pink color. So most of them are caused by iron, but as we saw with the grossular, you can also cause the pink with manganese 3. With those pyrospecialtines, the pink color is caused by the combination of iron, manganese, and trace amounts of vanadium or chromium in the stone. So what happens is the vanadium or chromium absorbs light, in the middle of the spectrum around 500 nanometers, and it creates two transmission windows in the blue and in the red, where light is able to pass through. And so if you have a cool light, which is dominated by blue wavelengths of light, you'll emphasize the blue transmission window, creating more of a purple color. Whereas if you have a warm incandescent light or candle light with dominated by red wavelengths of light, you'll emphasize the red transmission window, creating a more pink or pure red coloration. So the root cause is that you have two transmission windows in the blue and the red, which is causing that color change.
OK， 简单来说，就是他刚才也说，16石每个品种其实它致色原因不一样，有铁致色的，有铬致色的。然后这个变色的16石，咱们最后一章这个幻灯片上面这个，其实它是跟这个里边的这个钒这个元素有关。然后它这个元素的出现是会让它的可见光谱上其实是有它会出现2个透射光窗。然后这2个透射光窗呢，看您用的是什么光源，然后这个光源就会起比较大的作用。如果这个暖色调比较多的光源，它就会这个激发这一部分的光，然后冷色调多一些的光源呢，就会激发另一部分。所以这个是为什么它有这个少量的颜色变化的这个原因。我看因为时间关系，我们现在只有2分钟了，所以不能再回答其他问题。我会把这个问题会转给 Aaron, because only 2 minutes left, so we won't be able to answer more questions. There are a couple more, we'll send it to you. 现在您看到的是屏幕上是我们 GIA 的一些这个社交媒体的这个链接，还有二维码。然后如果您感兴趣的话，可以扫一下二维码，然后定时收到我们的信息。今天差不多就到此为止，感谢您来参加今天的知识交流。We'll wrap up, Aaron, and let's say bye.
All right. Bye, everyone. Thanks for joining.
Bye-bye.